In this video, we're going to take a look at three-dimensional suspension kinematics in Fusion 360. Hey everyone, this is Matt with Learn Everything About Design, and in this video we're going to carry on with our kinematics series, but now we're going to dive into three dimensions. All the work we've done so far in 2D sketches has been to help plan out suspension kinematics in a two-dimensional sense. Now, that allowed us to create some pretty detailed sketches that allowed us to play around with things like suspension arms and the location of the pivot points, the angles so we can get the instantaneous center, and that all is great. But at some point, you're going to want to take that into three dimensions. And the entire point of these videos is to find a way to shortcut the development process without spending all that time modeling different bodies and components just to figure out the ratios. So what we're going to take a look at in this example is the rotiform wheel that we modeled in a previous series that you can check out here. What I want to talk about is ways in which we can shortcut the system in order to get those kinematics. So in this example, what we have is a couple of bodies. We've got the hardware, the rim, the inside and outside rim, the hub portion, and we have the tire. And these are all portions of the wheel, and they all need to move together as one. And then we have this hub mount. Now, the hub mount itself theoretically is bolted to the wheel, or the wheel is bolted to it, and it contains a bearing. Now, depending on the car and the setup, you might just have a spindle on the upright, and there are different scenarios. And honestly, none of that is really going to matter because we're looking at everything as a rigid body. We're looking at everything combined as one, and we're not really worried about the rotation of the wheel at this point. So what I want to do is I want to put all of these together in a single component. Now, typically, when we start designing, when we are thinking about having a mechanical assembly, we start at the component phase. Now, this design here is just all bodies, and there's a good reason that I did it this way because I want to explain the difference as we go along. So when we're looking at this and we have all bodies, the implication behind this is that all of the sketches and features in the timeline were all done initially before a component was created. That means at the exact moment in our timeline where we create a component from this, all of those sketches, the references, all of the things that were used to create that no longer matter. Now, in some cases, that can be a benefit. In other cases, it can be a detriment. The way that I did this is I created a sketch or a couple sketches that have the location for the upper and lower ball joints, as well as the steering position. We're going to take a look at this as if it's a front, okay? So I did this at the body level, and I'm going to show you that when we convert these to components, how that can be problematic, and we're going to have to replicate it. So in order to do this, I want to convert all the bodies to components. Now, this gets a little bit tricky because we want them to all be within a rigid group. So I'm actually going to get started by creating a new component, and I can select the option to create a new component from bodies. When we do from bodies, we have to select the bodies we want. In this case, we have all of this hardware. Now, all the hardware was created as sort of a dummy. So you see we've created 30 different components so far. We're going to select the tire, and I'm even going to select the hub mount and say OK. Well, what ends up happening is we've created components for all of those things. And that becomes problematic because now the browser is extremely big, and it becomes problematic because it's a little bit harder to contain. So we're going to create another component. This one is going to be called the wheel assembly. So the wheel assembly, I don't really need it to be active, so we can go back up to the top, but the wheel assembly is going to contain everything else. I'm going to just select the hub mount, shift select the bolt at the top, then I'm going to drag and drop that into my wheel assembly. Now Fusion's going to do some restructuring, and you can see all of these move components, and essentially what we did was we made this new component, our wheel assembly, and we put everything inside of it. So what I'm going to do is shift select all these, right click, and I want to create a group. So again, it just kind of simplifies the timeline. You can see that we're able to expand and collapse. And the same thing happens automatically when we turned all those bodies into components. But one thing you'll note is that the sketch that was associated with this has kind of stayed in this position, which means that the sketch itself was not referencing, or it was not created at a point where this specific body had its own coordinate system. And that's where it becomes problematic, and you need to be really careful about when you do this in your own designs. So it's better off if you have components early on in the design. Ideally before you create your first sketch, you create a component and then you begin working in it. If that is not the case, if you're starting with bodies, then just make sure that when you begin to create these reference sketches that you are able to do them at the proper time. Before I create any reference sketches, I'm going to select the wheel assembly, go to Assemble, and I want to create a rigid group. A rigid group, including all child components, will include all of those 30 different bolts, and now you can see that this moves around as one. Now the next thing I want to do is I want to recreate or create this reference sketch or sketches, and I want them to be in that component. Now there is a little trick to this, is we could actually determine the point at which we created those components, and we could put those sketches directly in that component before it was converted. But that's not usually the case. Sometimes it breaks, and especially when we convert 30 plus components or bodies to components at once, it becomes a little tricky. So we're just going to pretend like we never even created these, and we're going to recreate them. Now the important bit to this is we need to be mindful of the fact that this component, if we find it in the browser, so let's select it, right click and select Find in Browser. It's going to expand it for us. It's going to find that component and find the body. We need to make sure that we're creating that new sketch reference inside one of the bodies or components that are associated with our wheel assembly. Ideally the hub mount or spindle or wherever you want to place it. So let's go ahead and activate the hub mount. And if we want, we can right click and we can isolate it as well, which gets rid of everything else, just makes it a little bit easier to see. Even though we've isolated, we can always go back and we can show sketches that we want to use as reference. So for example, this ball joint location. I do need to be extremely careful that I don't make any sort of relationships, so I don't want to click on these and project them, but it's going to help me sort of just plan out where they were. We're going to start a new sketch. We're going to use the coordinate system associated with this component. I'm going to go to Create, Project Include, and I'm going to create an intersection that happens on my sketch plane. Then I want to recreate this. Now, the reason I put a circle and a line there was only for me to represent the location of the ball, the portion of the ball joint that is actually our pivot, and then the axis in which the ball joint was mounted. And typically, you're not going to have these be vertical or they're not going to be in line with each other. It's going to depend slightly upon the setup. And honestly, the direction of this isn't really going to matter for what we're doing, but it's never a bad idea to create these references. So I'm just going to create an 1.5" ball. And I'm going to create a line that comes down, and I'm going to say, okay. I'm going to repeat this at the bottom, and I'm going to create a line. Then what I want to do is I want to make both of these equal, so they're both 1.5". And then I need to determine the angle and the direction or the length of these lines. And again, it's not really that important, but I think it's a good idea for us to make sure that we understand where these references can have an effect on the design. So I'm going to create align dimensions. I'll make them both 2 inches. And then I'm going to give these an angle between my projected reference. It's a good idea now at this point to make sure that we hide that original sketch so we don't accidentally select anything. I'm going to go ahead and make this 14 degrees. And this lower one, I'm going to go ahead and make 10 degrees just so they're different. I'm going to hit escape. Then I want to pull them and put them in roughly the right location. Again, I can take a look at my ball joint locations to see roughly where I put them. I could also bring back the wheel assembly if I wanted to see where the actual wheel is. But again, this is going to give me what I need. Now I know that it's in about the right location. This one, again, is in about the right location. I'm going to go ahead and hide that original sketch. Now, ideally, we know exactly where these are in reference to our assembly. I'm just sort of picking random positions to put them. And again, 2.5 inches, it's about right. I'm going to go ahead. This one is 1/4 inch in front. And then let's go ahead and pick a vertical distance, 3.325. And the angles are defined. Okay, so these are my upper and my lower ball joint positions. Now, what's important to understand is those are going to move around with my hub. And that's really why it's important, because if I bring back the original, you can see that that stays in position because it was created at the top level of the design when everything was a body. but we really need those positions to move in unison with our design. So you have to make sure that those references are in there. And also, I put another position for the steering if we wanted to account for the steering, things like bump steer. So let's go ahead and recreate that as well. In this case, I'm just going to sketch on the top. Again, I want to use create, project, include, and intersect. I want to figure out where I'm intersecting this flange. If we select this face, we can sort of pick the center. Then I'm just going to create a circle. This one is going to be 1 inch, and then I need to just pick its position. So dimension off of this face, I'm going to say it was 1/2 inch. And dimension from the center, let's say that we're 4 inches out. Okay, so now I have that location, and all of these are going to move with my hub and all the rest of the wheel. So now let's right click and let's unisolate to bring everything else back. And let's go back up to the top level. Another important consideration that we need to understand is when we're talking about mechanical motion in Fusion 360, we need to have components because components have their own coordinate system and are free to move about inside of the environment. So every design has a component that you build in, whether you know it or not. And that component has its own origin. And what Fusion 360 does is it tracks the location of the origin of every other component. So for example, our wheel assembly has its own origin. If we move the wheel, it knows exactly where it is in relation to the original origin. That's rotation and position. So understanding the difference between all of those is how Fusion 360 makes these assembly rotations work. So what we want to do is we want to make sure at the very top level of our design, we understand the nuance between having things at that top level and in reference to its own coordinate system, and having things at the component level and allowing it to move around. So now that we have a little basis for that understanding, let's figure out where we want the suspension positions to be. So I did mention that we need to have a component in order for assembly motion to take place. The catch to that is we can actually have a single body, and that's simply because at the very top level, that is going to be fixed in relation to its own coordinate system. So we can have bodies and sketches for those references, but it's really best practice to make a new component for this. So I'm going to go ahead and make a new component. I'm going to call this chassis. And the catch here is to make sure that the parent is the very top level. Now, if something is active, so we're currently active at the very top level of our design, that's automatically going to be the parent. And then we have this activate option, which means we're automatically in edit mode inside of there. I'm going to go to a front view. I'm going to start a new sketch, making sure that I'm selecting the plane that's displayed. That plane is going to be inside of my component. And now I need to pick the location for my suspension. Now, ideally, what we would do is we would base it off the origin. And if that's exactly what you want to do, the trick to that is using move before you start sketching. So if we do Control Z to undo, I'm in a front view. I'm going to show the origin of this chassis component, and I'm going to use move copy. Make sure that we use move components. Make sure that the component we're moving is the chassis. And then we can simply pull this over a distance inside. In this case, let's go to 20 inches. That's from the center of the wheel. And we're going to capture its position and say OK. Now, if we start to sketch inside of this chassis component, my origin's now over here. So now I can use this as the basis for my design. For this example, I'm not going to go really deep into all the nuances of the suspension geometry. In the last video, we talked a little bit about instantaneous center and roll center and the projection of those lines. I really just want to get to a position where we can make some assembly motion happen without wasting a bunch of time modeling components. So I'm going to create my upper suspension position. I'm going to make sure that it's slightly lower than this. You can see that it's on this horizontal line, which is at about 5. So I'm going to just put it slightly below that for that point. And this one, I'm going to make roughly horizontal. I'm going to hit escape. I want to make sure that all 3 of these points are vertical. Now, I know that that's not typically the case. Most of the time, this point is going to be inside a little bit, and it's going to affect the suspension geometry. Again, I don't really care at this point. I just want to make sure that we can understand the example. So from the origin, I'm going to add a dimension. I'm going to give 4 inches for this one. And then we want to make sure that we have this fully dimensioned as well. Again, this is another important part of the process, is to make sure that our references are fully dimensioned. Let's finish the sketch. And next, I want to create a reference location for my steering axis. Now, while this isn't strictly required, we could lock this axis of rotation. What I do want to make sure we understand is that bump steer is going to be a thing. So we're going to just create a suspension point for the rack and pinion. So note we've got the steering point that we created. I'm going to make this one inward just a little bit. And then instead of dimensioning it, I'm just going to go ahead and use the fix unfix, and I'm going to finish the sketch. So now we've got points for our upper and lower suspension, and we've got a point for our steering axis. If we go back to the top level of our design, since this is a component, this component is free to move about inside of this coordinate system. So we're going to right click and we're going to ground it. Now what we have is the wheel assembly that can move, and we've got this component here which is grounded in our assembly. The trick to make this work is to understand that as-built joints, which make use of the current location of components, actually don't really care if there's any solid geometry at all. All they really are tracking is the coordinate system itself. So as long as we understand the relationships between all of the various points, then we can actually define the kinematics in 3D without ever having to worry about modeling anything, at least at this concept phase. So what we want to do first is we're going to create an as-built joint. We need to pick the joint type. Now in this case, what I want to do is I want to pick a ball joint type. But there's one step of this process that we forgot. Now, the thing that we're missing at this point in the game is a component that is representative of the A-arms themselves. So if we make a relationship between this point and this point here, and let's just do it for example's sake. If we make an as-joint or an as-built relationship, let's just say revolute, between our chassis and between our wheel assembly, and we pick the point of rotation. What this means is that this component is just going to simply rotate about that. And that's not really ideal for what we're doing. So we're going to Control Z to undo. Then we're going to create some new empty components. I'm going to call this one upper A arm. And I'm going to create another one again at the top level. I'm going to turn off the activate option. I'm going to call this one lower A arm. And I want to create one more for my steering link, and I'll just call it steering. So now we have 3 components. Each have their own coordinate system, even though there's absolutely no geometry. There's not even a sketch in there. So what we want to do at this point is now we want to start to create the relationships between these. When we're talking about the way in which an upper or lower A-arm interacts with the mounting points at the suspension, depending on how you designed it, you might have some rotation or some flex. In our example, what we're going to do is we're going to assume that we have a revolute position. So we have 2 mounting points, we have bolts going through, their axes are in line with each other, and that's how we're going to handle it. So let's go to as-built joint. We're going to do revolute between the upper A-arm and the chassis, and then the snap point is going to be that rotation point we created. Let's go ahead and repeat that process. This time, we're going to use the lower A-arm and the chassis, and then our snap point is going to be that lower position. Now we're going to repeat the process as built joint, but this time we're going to use the ball joint option. Now, revolute allows for 1 degree of rotational movement. When we have ball joint, we're allowing for 3 individual rotations about individual axes, so X, Y, and Z. We can lock these down and we can restrict their movement, but at this point, we want to make sure that the wheel can not only pivot, but actually rotate and account for steering. If you don't want to account for bump steer, then we can simply just do rotation. And another thing to note, because our components are all rigid, it's not actually going to matter which component we select, but just for continuity's sake, I am going to select the component in which we drew these sketches. But again, it's not really going to matter. And this is going to be between the upper A-arm, and then the snap position is going to be the center location of that ball joint. You can see that we've got the rotation for the pitch and yaw, and we can change those later if we need to. We're going to repeat that process. Again, same component. We're going to do it with the lower A-arm this time, and pick our pivot point. The last thing that we need to do is we need to take care of our steering. So the steering is going to be an as-built joint between it and the hub. And then again, we're going to pick that location. So we've got a ball joint set up there. And again, what we're going to have to do is really think about the kinematics of our assembly. And at the car itself, we're going to have a ball joint because this is not going to just travel up and down. So we're selecting steering and chassis, and we're picking the location. Okay, so now if we did everything correctly, we should be able to move the tire up and down through its travel. And we can see what happens with the steering as we move up and down. So we're rotating, and we've got the revolute axis about each one of these upper and lower A-arms. The wheel itself is mounted on ball joints because what's actually happening here is as we're moving up and down, because the steering location is inside or it's not in line with anything else, we just sort of picked a random spot, we're getting what's called bump steer. So at perfect ride height, we're sitting level on the ground, we're not accelerating, we're not braking, the wheel has no toe in. It's not steering at all. But what happens when we start to compress the suspension, you can see it's starting to go toe in. We can play around with the location of these points, the point on the spindle or the point on the chassis, and figure out where we want to put that. I just drew it completely on the horizontal plane, but we could also move it up and down vertically. If you want to set something like an offset plane and then adjust where that offset plane is, you can move it up and down and see how it affects bump steer. But this is a basic example, and obviously I have a lot of geometry because I have an entire wheel and tire, and I drew a sort of a fake hub just to be there. But we don't actually even need that much. We could create a two-dimensional sketch that shows the cross-section of the rim and the tire and the hub and the mounting positions for the suspension. Or we could just put the points in space and have a very basic representation as a box. And as long as that is in a component that has its own coordinate system, then as we move up and down, we'll be able to see the travel of the suspension. So this example, you can take it as far as you want to take it. This was a very introductory basic look. But before we finish this example, the last thing that I want to do is I want to show you what a motion study is and how we can use it in this example. So once you have everything set up, we're going to go to Assemble and select Motion Study. Now when Motion Study pops up, what we need to do is select joints that we want to animate. And this is going to be something we need to be extremely careful about. In this case, what we want to do is we want to select either the upper or the lower revolute joint. Now the reason we want to select the revolute joint is because we've only got 1 degree of rotation. So we pick this, and all we need to do is tell it the amount of angle that we want it to rotate. So from here, what we have is revolute, and it's set at 0 degrees. At 40, I'm going to just click on this line, and this line allows me to determine the angle. So let's say I want to see what happens when we go 15 degrees positive. Now, 15 degrees positive is actually moving the wheel in the opposite direction. So let's say -15, and now it's moving it up. Now, it's probably way past the amount of travel that we would ever expect, considering that this is where my lower arm is mounted. So let's say -10. Next, I'm going to go up to 80, and I'm going to set this back at 0. I'm going to set this to loop, and then we're going to play through. So now we can watch the wheel go up and down. We can increase or decrease the speed, and we can take a look at the position in which we are actually moving through. If you set this up properly and you do a little bit of extra work to, say, set up the steering geometry properly, what we could do is we could have the steering component comprised of 2 separate components. That would allow the steering component to actually turn or move and represent things like suspension travel while the wheel is turned. There's really a lot that you can do with this as long as you fundamentally understand that all of these separate elements need to be in their own components purely for the fact that they need to have their own coordinate system. As long as they have their own coordinate system and you put them in or model them in the right position, then you can use as-built joints and you can replicate any complex mechanical motion with just some basic sketch elements. So if you have any questions on this, please let me know. It's something that is probably a little outside of a normal workflow. Most people are going to go in and start to model things and then put them together and add those joints. But honestly, the power of Fusion 360 using assemblies with components and having their own coordinate systems actually gives us the ability to sort of skip the 3D modeling design phase and use this sort of functionality of as-built joints to see what things would do. Remember, the wheel, the tire, all that solid bodies that we have in here aren't even really required. The only thing that we need is to have the sketch reference points that we want to use, and we need to have an understanding of the kinematic joint relationships that we want to use in those. So again, if you have any questions, please let me know. And as always, thanks for watching, and I'll see you in the next one.